is going to be on Matlab. So all of you please go ahead, and if you have installed your Matlab software on your PC, please just open the Matlab software. How many of you have installed Matlab? Just raise your hand in the chat window. Only one. No one else has installed. Two. Okay. All right. So just open the Matlab window.
Excuse me, sir.
Yes. Yes. Go
Hello.
ahead. Yes. Go ahead. Yes. Go ahead. Somebody was asking something.
Sir,
Yes. Go ahead. Yes. What is your question? Yes. Somebody is asking some question and not responding. Smith Angara.
sir.
Yes. Smith Angara. You are asking some question.
Yes, sir. Could you change the settings to attendees only? I've been removed twice.
Okay. 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 तरी light लाव दे. All right. That is done. Okay. So now few more students have joined in. Uh, I have asked all the students who have installed Matlab program on their PCs, respective PCs, please open up the Matlab software. How many students have installed it? Can you please again once again raise your hand so that I can get some idea how many students are going to be doing this practical with me. All right, so quite a few have installed it. So just open up the Matlab software so that we can start with the practical. वरून दुसरा हा तोच 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 मला कदाचित थोडं आणखीन एक कप कॉफी लागेल काय काय नाही all right done. Okay, now all of you see, can you see the Matlab window? Varshil.
Yes, sir.
Okay. So here on the top, you will see this first button that says new script. So click on that. Right. So that will open the window for writing the script. So I will type the script simultaneously and explain what is being done, and simultaneously you can do it. Right. Okay. So first a program will be to study natural frequency and period, variation in natural frequency and period with static reflection. So we are going to study the variation in natural frequency with static reflection. See, the so omega n is given as square root of g by delta static. That is 1 upon twice pi. It will be in terms of hertz. 1 upon twice pi into g divided by delta statics. That will be in hertz, and the twice pi into root of delta static divided by g square root of that. That gives you the time period. Okay. So all this expression. See, I have created an assignment for you. So you can go to your Teams group, and if you go to the Teams group, Teams TMake DOM B1 group, and if you go to the assignments, see there is lab number 5. All of you are uh, able to see that lab number 5, study of damped and undamped vibration using Matlab.
Yes, sir.
Okay, in that go to open that assignment and see there are two PDFs that are attached. So that variate underscore one PDF. So download that PDF and open it. Alright, so can you see the PDF on the screen? So it says variation of natural frequency and period with static deflection. So you have to going to plot this variation. So equation for natural frequency is square root of g by delta statics, and time period is twice pi into delta static divided by g square under root of the square root of that. All right. So we are going to write the program for this. So let's start with that. Any questions? Okay. So whenever you write anything in front of percentage, that is treated as a comment. Okay. If you have studied, you have done C++ programming, right, in first year.
Sir, C.
C programming. So C programming, if you remember, you used to write comments, right? So whenever you write something as percentage, and if you write anything in front of it, that it is like writing a comment. Right? So that is the way to write the syntax for writing comment in MATLAB. Okay. Now next I am going to define some variables. So g is equal to 9.81, and after the variable u semicolon. Okay. So that is the gravitational constant. So again you can write a comment if you want. Everywhere comment is not necessary, but just to show this is the gravitational constant meters per. Right. Now I will define the static deflections. So for I is equal to 1 colon 100 and 1, 101, di is equal to 0.01 plus 0.05 minus 0.5 minus 0.1, putting into bracket, star is I minus 1 divided by 100. Okay. So what I am creating is I am creating a array for deflection. Okay. Write the comment. Defining array for static deflection. Right. Then I will define the array for natural frequency omega, or here it is W I, read it as omega I is equal to G divided by T of I, thing in bracket, and raised to the power of 0.5 semicolon. Alright. So this defines defining array for angular velocity. Right. Now let's define the array for time. So let's call it tau. Tau of I is equal to 2 2 star pi t of I by t, whole thing raised to 0.5 semicolon. Define array. So this is defining array for defining array for time period. And since, if you remember, since you start for, you have to end for loop by end, just like you did it in C. Okay. Next, so we have defined the array for deflection. We have defined what is defined array for angular velocity, and we are defining the we defined the value for time period. Okay, correspond to that static deflection. Now we'll plot a graph. Plot it d comma w semicolon, and g text. We're going to define it function called g text. So g text is get text, and we are going to input a string omega n semicolon, and hold on. So what does g text give? So it will ask your mouse to pick any space in the in your what do you say, in your graphical window, to place this text of omega n. Okay, that's all. And hold on. So until you place this text, the next line of command will not be execute. Okay. All right. So next, plot static deflection D versus tau. And again, get text. I, it is this second graph is for T, is for time. Okay. Then the label X label is delta. So whatever is to be labeled, put it in quotes. It is delta underscore static semicolon everywhere at the end of each statement. Give this semicolon. Otherwise, it will the output will be displayed on the window. Okay. Then give the title for this graph, natural frequency, comma, natural frequency, comma, period versus static deflection, semicolon. All right. So this is your program. Okay. Once you have written the program, save this program. Save this program in. So I'm going to save it in my directory. So make some directory where you want to save the program. This is for E1. So first is now whenever you give the name, do not give any space in between. Leave any space between the name. Natural underscore frequency underscore period underscore static underscore deflection. So your name should not have any space in between them. Otherwise, the Matlab doesn't accept that name. All right. So I'm going to save the program. Right now, click on the this play button, run, and it is ask to ask. It will ask you this various option to do change folder. Okay. All right. So this is the output basically. See now, because of the G text, it is going to ask me to where to place the text. So the first graph is of omega n versus static deflection. So place somewhere on the graph. Once I place it, the second graph, that is time versus static deflection, will appear. So place it on the text, and then the horizontal axis delta static. All right. So this is your first program. Okay, those who have installed software are able to get this output. Those who are done with this program, save the program and upload it as a response to the assignment.
So can you demonstrate the graph once more? How do you get the graph?
Uh, you just run the program. Just click on the upper arrow. So the name of the program. Just type it, or you can just do up and down arrow. It will pick up the name and just press enter. That will give you the graph. So then this, because of the G text function, it is asking you to place that omega n text somewhere adjacent to this first graph. Okay, so this is omega n versus the delta static. Then the second graph is the orange one is time versus delta static. So place the text for Tn and then horizontal axis delta static.
Okay, thank you, sir.
Also take a see. You can also save this graph. Save to
Sir, do we
save
have to upload the code file or I mean the code
code
or
and the graph both.
okay, sir.
So right now you have to just upload the code and the graph so that I will know how many students are doing it with me. All right. So this is the graph underscore one. I will write. That is for the first program. Okay. And I will save it same file. At the end, you have to make PDF of all these files and merge all these files and submit it as a single file. But right now, I want to track how many students are doing what. Let's Now, one more thing I would like to point out regarding the attendance. So, see, now the attendance for uploading the attendance on the portal. See, we download this attendance at the end of the lecture, right? You all of you are aware, right? When I go here and if I do the download attendance list, I get the attendance of all the students. Okay. Now, if what happens is that many of the students they are logging in and logging out continuously out of the software. I don't know for what reason, but if you do that, see the software only calculates your total time for which you are logged in. All right.
Sir, we don't log out, sir. It is because of the network issue that we face. We directly get logged out of the this.
But yeah, see, even if you have a network issue, if you are logged out, again you have to log in, na? See, if
Yes, sir. Yes.
you are facing network issue, you might be facing it for like a few seconds. That doesn't matter. But some of the students are doing what? They are logging out and then they are not logging back in for a long time. All right. So then the your total logged in time, if it is less than 75%, okay, so the lecture is 1 hour, and if your total logged in time is only 45 minutes, then you will be marked absent automatically. All right. So some students I have found out that they are not attending or they are doing this business of logging in and logging out continuously. Even in the attendance sheet, I can see this happening many times. If you are just logged out for few minutes, few seconds, that is okay. But you have to log back in. Otherwise, your attendance will not get counted. Okay. So this has been observed for like all subjects. Comparatively less for my subject because we are also doing quiz during the lecture. But no, I am telling you in advance. Now the attendance sheets are going to be directly uploaded. It is not going to be marked manually. So if you are doing that, I would urge you to stop it at the earliest. Okay, once you log in the meeting, you should not log out until the end of the practical. Okay. If, so if your practical period is of 2 hours, then you are mandatorily required to at least attend the practical for 1.5 hours. Okay. Even if somebody leaves you early, like someone finishes out the practical early for 1 hour. At the 1 hour, if your practical gets over and if you are stopping, the software has inbuilt time of 2 hours. All right. And if your whole session is only of 1 hour, then it is all of you have attended only 50% of time, then all of you will mark absent.
Sir, what if the teacher tells us to
That
leave?
is, I'm not. Don't want to discuss about other subject, but I
Okay.
want you to understand that you discuss with other teachers. Okay.
Okay. Okay.
Right now, try to understand what I am telling you, because as far as DOM practicals are concerned, I am not leaving you early even for a single minute. Entire 2 hours are engaged, so you cannot give excuse for DOM that it was left early. You can check all the recorded practicals. They are all of 2 hours. All right. So in in case of dynamics of machinery, this is not the. It should not be the case that nobody can say that it was only the session itself was of 1 hour, curtailed after 1 hour. So all these things you have to keep in mind. Unnecessarily complications might arise, so you should avoid that. All right. So first program is done.
So,
Yes.
sir, actually, I'm using the online version of Matlab, so
Ah,
I am not able to export the file onto my laptop. So, can I upload a screenshot of it?
no, you can upload it later.
Yes,
See,
sir.
I am not like what do you say, cross checking and evaluating it whether somebody has uploaded it or not. I just want have a good grasp of how many students are actually doing the practical. So if there are any issues, any such issues with the online version, etc., etc., no, you can just save it on the online version. At least, are you able to save it?
Yes, sir, it's getting
Uh,
saved on the
uh,
drive of
so
Matlab.
just save it for now, and then later on when you are able to what you say, recover it from the drive, you can do it. So as I can see, only two students have turned in.
Sir, I
Raj,
also turned in.
Raj Anatkar and Vaishnavi Nambiar. Only two students have turned in. Okay, not an issue. I'm not like making it mandatory submission. I just want you to like follow the MATLAB session. No? Otherwise, it is of no use. Okay. So what I'm doing is I'm just giving you some basic programming skills. Okay. It is not possible for as a part of this course to do a full-fledged MATLAB program. So actually, when you are in your break, I used to suggest you to do this Coursera courses. Okay. See, today and tomorrow are the 2 days are the last 2 days for registering for Coursera courses for doing it for getting it free. I think 30th September was the deadline. So after 30th September, then all these courses will become paid. There are many courses on MATLAB in Coursera. So I would urge you to enroll for these courses. The advantage of that is that for the duration of the course, at least for 1 more month, you will get free access to MATLAB also. Okay. So there are uh, multiple benefits of doing that course, and also then it is a very useful language to learn. I also suggested students to go for Python, but I don't know. We are not going to do anything in Python because MATLAB is much preferred as far as for mechanical engineering is concerned. According to Python is also very useful, but we are not going to do Python. Okay, so this is the first program. Okay, so I hope all of you, those who are writing it along with me, have saved it. Just closing this, and I will go to the next program. New script. So we are going to do the second program. In this program, we are going to study the undamped vibration. Okay, I will just start by writing the comment. So first, we are going to study of undamped vibration. Right. So first thing you need to do is define variables, or variables. A better word will be define parameters. Right. So first thing I would like to define is the amplitude of vibration. So amplitude, I have done some calculations and I got it at 27.98. Each statement should be accompanied by semicolon. So what is this? This is the amplitude. Amplitude in millimeters. Alright. Just a good programming practice is to always write comments. Omega n natural frequency is 100. Write the comment. Natural frequency in radians per second. Zeta is equal to 0.1. Again, semicolon. I missed the semicolon here. Semicolon. This is the damping ratio. Damping ratio. Omega D is equal to omega n sqrt square root of whole thing into bracket 1 minus 1 minus zeta square whole thing into bracket semicolon. This is the damped natural frequency. Damped frequency in radians per second. FD in hertz is omega D divided by 2 star pi is the damped frequency in hertz. Tau D is equal to 1 upon FD semicolon semicolon. That is damped period in second. Pi is equal to 0.466. That is a phase angle. Phase angle T is equal to 0. So I'm going to define the span for time span in seconds. So T is equal to 0, starting with 0,
Sir,
colon, yes,
phase angle in radians or degrees?
phase angle in radians,
Yes.
angle in radians, colon, tau D by 100, colon, 6, star tau t semicolon is time span and in seconds, right? Then it will define displacement. Displacement define displacement displacement. Right. So write down the expression for displacement. X is equal to a into e raised to, that is exponential, minus zeta star omega omega n star t dot star cos omega t star t minus phi bracket close it. Okay. So a e raised to minus zeta omega n t cos omega dot cos omega d t minus phi. That is your equation for displacement. Okay. Now let's plot the
So what does
response.
the dot signify?
What is dot? Dot is for this matrix operation. Okay. So that each term of that matrix should be multiplied. So you should get an array. Okay. You should get an array of displacement, because we are going to plot the array of displacement versus time, x versus t. So if you are just multiplying any two quantities a into b, you just write a star b. But if you are multiplying that with the matrix, all right, so then you will require that dot t.
Sir, can you explain line number 10?
Line number 10. See, I
Yeah.
have created a time span of t. Tau d I already got it from here, right? Now I want to create a discrete time scale. So the time scale starting from 0 to some arbitrary value 6 times of tau d. So time period for one is what, tau d, right? Time period for one oscillation. So I want at least for six such oscillations. So I am making it till 6 times of tau d. Got it?
Okay, sir.
Once the output is there, no, I think it will be more clear. Okay. So then next you have to plot the response. Plot the response. Figure 1. So this is
Sir,
just, yes,
sir, what is that EXP?
exponential. So a e raised to minus zeta omega t, right? So e is
Okay,
replaced
okay,
by
okay.
exp.
Yeah, yeah, yes, sir, got it.
So next now we are going to plot the graph. So this is just the syntax of plotting the graph. So plot t comma x comma k comma minus bracket set g c a comma font size comma 14 bracket. Now if you see, I am not putting semicolon everywhere because I want this output to be displayed. Okay, so since I want this output to be displayed in the graphical window, I am not putting semicolon anywhere. T bracket S. Alright, so X label is T, Y set, sorry, Y label is X. So whatever is the label, you have to put it in single quote. X in millimeters. Grid axis. We are going to define the axis. We put it in square brackets. 0 max of T minus 29 plus 20. Right? So basically, you are defining the graphical window. You are giving the what should be the maximum and minimum of the graph. So 0 to max of T is your x-axis. Max on x-axis, maximum distance will be T. And if you see, your amplitude is 27.98. So slightly more than that. So minus 20, and it is going to go from plus to minus, right? So, so it is minus 29 to plus 29, slightly more than that. Okay, so that is the logic behind defining this axis.
Sir,
Yes,
sir, in 15 line, what is it? K dash, K minus.
T will be just, it will be on the graphical window. You will see it. Okay, it's just like a legend type. Just now let's run the program. Now let's save the program. Save and save it here, and this will be under so damped underscore vibration. Damped. Save. Now whenever you are going to run the program, first make sure, see, can you see this small window workspace? It says workspace on your left hand side. See, one is current folder. Below that, there is this workspace. Are you able to see it?
Yes, sir.
Hello. Huh? So
Yes, sir.
in this workspace, you will see all the variables which we are using in the program, which are getting defined, are getting displayed over here. All right. So what happens is that you might write multiple programs. So no, it is always better to when you run the next program, type in clear. So when I type in clear and if I enter, see all the variables are now gone. All right, all the variables which were stored earlier are gone. Now I will run the program. Let's see if we are able to run it under damped. Under, okay, under damped vibration. Enter. Ah, see, I did not close the graph. Okay, see, I need to close the graph. Okay, I will just do the clear. Otherwise, it will get. So close your earlier graph which you have plotted and just type in the name under damped vibration. close this program. All right. Okay. So this is how you should see the output. Are you able to see this in this format?
Sir, could you show the code once again?
Just a minute. Oh, it's code. It's complete code.
Sir, why we have to write that 2-3 times clear and then?
See what happens is that sometimes what happens. See, I'm using some defining some variable in one program. Okay, and by chance, now example t is a common variable because I will be doing all my program based on time. So I'm writing t here, and I'm also writing t in another program. And since everything is under same folder, then the space is getting overlapped. So you might have defined t something else in an earlier program, and again I'm using t here. So what might happen? The data might get mixed. So
Yes.
always, in fact, at the beginning of the program itself, you should write the statement clear.
And sir, in a 15 line, what does that GCA means?
GCA is the it is basically
Is it an
setting this.
attribute for font?
Yes, this is when you plot this graph. No, this are the attributes for this graph.
Okay, okay.
So you can play around with that.
And sir, in this, we don't have any plotting like things which we have done it before by using GSEC, I think.
So I have not used that gtext. Nah, that you can
GText.
like you can use the gtext command here. Okay, so what I'm going giving you is set of basic programs. You can like write more complex program by now by using the earlier command. So you have to like cumulatively you have to add up your programming skills by learning more and more things. So you have to like keep on. You can use programming commands and from one in other, so that you can do it. See now here, one more thing I would like to point out is that see this is the when I plot the output, this is for underdamped vibration, right? And for underdamped vibration, the
Sir,
expression
I'm
for
not getting the same graph.
you have to check the code. See, just check the code which I have displayed on the screen
Yes, sir, I checked.
because I'm just doing it right in front of you, right? Something might have missed or sir, I will give you time to go through it,
Yes, sir.
or I
Sir, on
can.
the ninth line, why we have written tau d by 100?
Where which line?
Ninth line, ninth.
Line 10,
Ninth.
9. Tau d by see this time interval na, on the graph. I want to plot it for each individual time. So see, if you see this graph, yeah, if I move this graph, can you see these points? Right. So many discrete time intervals are defined by using this line. This t is equal to 0 colon tau d by 100 colon 6 times tau d. So tau d is so how many peaks are you able to see here? Can you tell me? 1, 2, 3, 4, 5, 6. Got it? So you got it for 6 tau d. Okay, so 6 cycles. 1 peak to peak, 1 peak to peak, 2, 3, 4, 5, and the sixth one. All right. So why you got only 6? Because you have defined here the time span from tau d to 6 tau d. All right. In fact, see now you as a good programmer, it is always be write very descriptive comments. So you can write here 6 tau d will give output for 6 cycles. Right? Now let's change this. Let's make this 7 tau d. Right? I'm just closing the window. All right, and just run it again. See how many cycles are there. 1. Let me enlarge. 1, 2, 3, 4, 5, 6, and 7. Got it?
Yes, sir.
Okay.
Sir,
Yes.
sir, is it necessary that we have to follow a particular
I'm not able to
chronological
hear
order?
you. I'm not able to hear you.
Hello, am I
Ah,
audible now?
yeah, yeah.
So is there any chronological order that we have to follow? That first we have to mention zeta, FD, tau d.
No, no,
Uh,
no, no
it's
chronology.
fine now if we write before and after.
Unless see, if I am writing FD here, that is omega d by twice pi. Okay. So first, if you are
Yes.
writing this, then you have to first
That
define omega d.
next formula should be regarding upper ones.
I think it's. I don't know. I have not tried it. Generally, I do it in this way because if I'm using some variable in my statement number 2, then it should be, and if it is some kind of expression, then it should be described in the earlier statement.
Yes, okay, sir.
All right. Are everybody is able to get the output? How many students? Okay, those who are able to get the output, just unturn your earlier submission and just turn in this second program and graph. This graph again you can save it. Where is the graph? Okay, posted I think. Okay, just go here to save on this graph and just I'm going to call this as graph.
Sir,
Yes,
in line number 14, what is K minus?
K minus is Record it. Where it go? Oh, it is just the color. See, if you remove that K minus, see the graph now appears blue color. Okay.
Okay, sir.
See, if I put P minus, see the what happens. It gives me all stars. Basically, it is just manipulate that. The legend, manipulate the legend of the graph. All right, everybody's done with the second program. Can we start with the third one?
Sir, you have given us this program in PDF, like a previous one which you have submitted.
The previous one was in PDF. This is not in PDF. So
Sir,
after I complete both the sessions, after that I will give you the code.
okay, sir. Okay, sir.
All right, can we start with the next program? Is anybody uploading? Few students have.
Sir, can we upload at the end of the lecture?
Yes, yes.
Thank you.
Okay, so most of you have got it. So let's do the another program. So this program is for simple pendulum. Sticky. Okay, I'll just come back in a minute. Okay, I will just close this program. Start with the new script. Okay. So if you see in your assignment, just open up your assignments. And there is the second PDF pendulum equations. Just download that. Just open it in my PC. All of you are able to see this PDF I opened. Hello, Varshil.
Yes, sir.
Okay. So we are going to next program which we are going to write is for this simple pendulum. Okay. So we have already solved this in our theory. So we have solved for the equation of motion of this simple pendulum, and this is the governing differential equation. Okay. Now the important thing to note here is that, see, the governing differential equation is theta double dot is equal to minus g sine theta t divided by L. Okay, so this governing differential equation, here we have not done that sine theta t as theta. We have derived this governing differential equation for large oscillations, not only for small oscillations. For small, so this is applicable for small as well as large oscillations. Okay, so this is for undamped. For damped, the damping term is added minus c theta dot. All right, so here damping is obviously provided by viscous damping is provided by air. All right, so air is a viscous medium, and that is what is providing the damping, and which will cause the oscillations to die out. All right, so this is how the what do you say, the equations will be set up based on this theory. Okay, so I will write. We'll start with the code. Okay, so this program. So the first comment calculates the angular position, velocity, and acceleration of a simple pendulum, as a function of time. Also calculates the tension in rod or string. All right. Next, do clear all. All right. So, or whenever you write a program, when you start this program, always write all these commands: clear all, semicolon, close all, semicolon, and yes, semicolon. All right. So that will close, clear, close, and it will clear the workspace. Okay. All right. So next, we will define the various parameters, and for this, all units are in SI system. So M is equal to 1 kg. So I'm not going to mention the units again and again. That is the mass of pendulum knob L, this is L, it is a variable, it is not 1. L is equal to 2, that is the length of rod or string. G is equal to gravitational constant, that is equal to 9.81. 9.81. Acceleration due to gravity. T is equal to 10 seconds. So this is your simulation time. Simulation time. T equal to damping coefficient, that is 0.25. Damping coefficient. T step. T step is equal to step is equal to 0. Time step. This is a time step 0.01. Simulation.
Sir, we cannot write the same thing like we wrote in last code in time means 1, then semicolon, then 0.1, and then
Here I have tried something different, so you can write it in that way also. But now follow just the step. Later you can tweak around with it. T is equal to time step is 0.01. Simulation time step. Okay. Iterations. Because here I will be using this variable in a slightly different manner. Iterations is equal to T divided by T step. I guess you can total number of iterations, but here for some students it will be easier to understand what exactly is being done. So now I will see, now I will define T is equal to 0 colon iterations, because here then it will become it becomes too tedious to read. Vector time vector for plotting, time vector for plotting. Now we'll pre-allocate some variables. Pre-allocation of variables, just to define the starting point of variables for speed, right? Just like giving the boundary condition. So theta is equal to zeros. Size will be iterations comma 1 semicolon. I'm just going to repeat this. Shift from Control C, Control V, omega, omega, Control V, alpha, alpha, T. Alright, so theta, omega, alpha, T all are defined. And then theta, theta, make sure you keep the spelling same. Theta 1, comma, colon, colon is equal to pi, pi by 2, semicolon. It is angular, initial angular velocity, omega 1, colon. There is just the syntax how you do it. Is equal to 0, semicolon. Okay, this is not initial angular. Theta is initial angular position, not velocity. Position and initial angular velocity alpha 1, comma, colon is equal to 0, semicolon. This is the initial angular acceleration. So x dot x dot x double dot at t is equal to 0 are defined. Okay. Now define the loop, that is the iterative loop for solving the equation. So for n equal to 1, iterations, iterations alright, so this is iteratively I am solving this equation, iteratively solving this, solving equations using Euler's method. Euler's method. Right, so we will see what is the Euler's method. So theta n plus 1, comma, semicolon is equal to theta n, comma, colon plus omega n, comma, colon. star. So theta is equal to theta 0 plus omega n t. That is what I am writing. Omega time t steps. It is the new angular position. Alright. So theta is equal to theta 0 omega n t. So next angular position is the initial angular position into the angular velocity omega into t. That is our normal equation that we write. Alright. Now similarly, omega n plus 1 comma semicolon bracket is equal to omega n plus alpha alpha n comma colon t step. So this will define the, so that is the omega is equal to omega 0 plus alpha t. Right. So this will define the new angular velocity. Right. So all these things have to define in terms of in a matrix form. Similarly, angular acceleration alpha n 1 alpha n plus 1 comma colon bracket is equal to bracket minus g star sine theta theta n plus 1 comma colon goes the parenthesis three parenthesis 1 2 3 that closes everything divided by L minus L minus C star omega n plus 1 comma colon bracket semicolon. This is the new angular acceleration. Angular acceleration. Acceleration. Okay, and this I have got from this PDF, the pendulum equation. All right. So last statement was nothing but this expression theta is equal to minus g sine theta by L minus C theta dot. Is that clear to all? I hope that is clear to all. Yes. Yes. Yes.
Coding
Please
part,
go.
coding part.
Uh huh.
Sir, in this line number 14,
Uh,
uh, t equal to 0 colon iteration means what will be the output in Means what is the purpose for
Basically,
it?
this is the various time steps that are being defined. All right. So earlier we did it in one single line. Here I have just broken up those that whole thing into just sub no intermediate steps. So it is easier to understand. That's all. It is the same thing which timestamp we have defined in the earlier program. All right.
Sir,
Okay. So yes.
sir, can you explain the defined statement of theta in line number 16? What is that zeros?
So this is basically initializing all the values in the arrays so that nothing is left blank. And as you all these zeros will be replaced by all these values which I am writing in this code. This is just initializing it.
Okay.
So, sir, all the zeros will be replaced by that iteration format
Data,
that we
yes,
will
by
take,
the
right?
data. Yes, it should be replaced by the data.
Okay.
Right? So t n plus 1 comma colon bracket is equal to m into g into cos bracket theta bracket n plus 1 comma colon bracket plus m into L into omega n plus 1 colon whose dot, because it is a matrix, whole raised to 2. Alright, this is the expression for the tension. Alright, the equation. So what I have written is the equation for tension. Is that clear? ml omega square plus mg cos theta. Alright, ml omega square plus mg cos theta. Alright, so this is the expression for tension in cable. And then we end this loop. Alright. Now next step is the plotting. Alright, so next step is to plot angular position, velocity and acceleration. Alright, so again, for when you plot, go figure, that is the first command. So that means it opens that figure window. Okay, subplot 3 comma 1 comma 1. Right? Plot time t versus theta colon r theta dot 180 divided by pi bracket complete comma. So just legend. I am defining the legend for various type of plots so that they will be able to identify. So y label theta theta. So I converted this theta into degrees basically. Bracket
Sir, you missed an inverted commas over there on the plot theta, I think.
I don't think so. Let me check. Wait back. That degrees. Let me get back to that. Let me just complete this graph plot first. When I compile it, if there is an error, it will show it. The title. Oh. So this is for the first plot. Angular quantities as a function of time. So subplot 3 comma 2 3 comma 1 comma 2 plot t comma omega g dot semicolon. Okay, so that is t versus angular velocity. So time versus displacement, that is angular displacement, time versus angular velocity, and y label omega bracket radians per second semicolon and close it. So
So,
what I'm doing is I'm dividing the plot area into three plots. I want to create three plots, one below the other. So that is why this is three under 311. So 312 and 313, like that it is. Yes, go ahead.
sir, why there is single apostrophe in omega in
I
line
think
number 18?
that is just the what do you say, the syntax.
Okay.
Yes. So just you will see it when I complete the plot. So let me complete 3 underscore 1 underscore sorry comma 3 semicolon plot t.
Sir, in previous to subplot, you didn't put semicolon.
Okay. Yes. Semicolon t comma alpha comma r dot semicolon y label alpha. This is the angular acceleration radians per second cap X label is for all iteration. Iteration. Okay. Then we'll also plot the tension. Plot tension in a rod. Alright, so will be figure semicolon hold on semicolon plot capital T extension comma so what it does, it takes the values from the expression C dot semicolon plot T comma M G comma K dot semicolon X label iteration Y label tension newtons semicolon title tension in pendulum rod as a function of time. All right. Now let's just save this program. Uh,
Sir, I have a doubt.
just a minute. Just a minute. Let me just save this program. Let's just quickly run this program and then we'll address all the doubts because the time is just about to end. Let's just first run this program and let's see. Uh,
Sir, in line number 51, the
yes. All right. So this is the graph for tension. and this is the graph for. All right, so this is the graph for angular acceleration versus time omega, that is angular velocity versus time, and theta versus time. All right, and this is a graph of tension versus time. All right, okay, as you
Sir,
can
what
see,
did you change when you got that error?
I think there is some minor error, some semicolon or something like that, parenthesis or. Yes, yes, what we are asking.
So, sir, in the fourth line, so top in
uh,
starting, clear all means you have cleared all the program which you have written previously, right?
yes,
And close all
so
means
it will, I think, close all the. So if you run this again, the see, if I run this program again, see now here these graph windows are open, right? See these windows. Now if you don't write
yes,
that
yes.
close all, na, this windows will. So let's see what happens if I don't just make this as a comment. So now I have not uh, see close all. I have not done that close all. Now if I run this program again, so now what will happen? See, do you see? Initially there are two windows from the earlier run, and now again two more windows are created. Got it? Now if you run it again, what will happen?
Yes, sir, got it. And sir, what is that CLC?
That is also it basically clears all the workspace. At the command prompt, it will clear all the whatever you type. It will clear it so that you have a fresh. You are starting a fresh iteration. That is helpful in debugging the program.
Okay, sir, in 19, 20, 21, 1 comma colon means what will colon will do there?
So this is just the defining the value at that position as the initial angular velocity. Because all these are arrays, right? So all these are arrays with respect to timestamp. So initial angular position, velocity, and acceleration are defined here. So theta initial is pi by 2, and then once the initial from this, see when I am doing this now iteration over here, see I am starting with n is equal to 1. All right. So here when I am going to theta and theta 2, so here it will be taking theta 1 from here, that is pi by 2, plus omega n into time step, that is omega n t. So it will be pi by 2 plus omega 1. So omega 1 is what, this one, 0. All right, into t. All right. So omega n1 is also omega n into alpha into t. So omega 1 is what, 0. So here again it will take 0. All right. Now then for the next step, now n has changed from n to 2. So now here it will take from 1. 1 is whatever is stored here. Like that it will go on creating the array. Same thing for tension.
Yes, there is line 29 in tensile formula. In
Uh-huh.
English, we have put that dot square means what
Again
is the
it is a
meaning for
matrix,
this?
na? I'm not squaring like a single term. I'm squaring each and every term in the matrix. So I have defined a matrix, and when I'm writing it, it should writing the expression. It should give me it should generate a matrix of values of tension. So it has to generate all these values, right? All these values. So it has to do this operation for each and every value in the matrix of omega. not just one value. Excuse me. So that is why it is for dot. Okay, so it will take some time for you to like familiarize yourself with the syntax. Each programming language has its own syntax. So that is how you will just
So
basically write the
sir, once in
yes.
line 29 we have defined matrix by putting the dot. So again, in while
Which line?
plotting
Which
in a
line?
line
Which
29,
line?
29.
Okay.
So we have given the dot in the last. So
Uh,
again in 35th line while plotting, we have to mention dot again.
45th line. We plotting
35.
of tension. 35. Just 35. No, here.
Yes, sir. There also dot you have put in
Huh.
after theta.
Yes, it is put. No, dot is put.
No, sir. I am asking that.
Yes,
So
yes.
there also same thing. We have to do matrix. That's the reason you have put or something else.
No, here, like I have put it here, right? For 35th line, na?
Yes,
Line
sir.
number 30,
35.
plot t comma theta. See, I put that dot over here again because again it is a matrix, na? So I want to multiply each and every term of matrix by. So I want to convert each theta will have all the values in radians. So I want to convert each of that value into degrees. So I have to multiply each term in that matrix by 180 by pi. So that is what is done.
Okay, sir. Sir, can you scroll down? 1 second.
Sir, on line 35, what does theta dash indicates?
Line 30.
5. Sir, where the cursor is theta, then you have put one.
That is just the
Sorry.
syntax of for getting all those values from that matrix theta. It's just a syntax.
Sir, after theta, you have put a semicolon
See,
but not closed, means colon but not closed
that
it.
is syntax. See, everywhere there is only one colon. See, again for omega, one colon, alpha, one colon. Alright, so it gives the matrix of all the values. See, again
Sir,
here,
in line
plot.
47.
Huh?
Sir, in line 47, yes, what does that hold on means? Hold.
Hold on, means see, here you are plotting two figures, na? So after you plot
Yes,
one
yes.
figure, it will not close that figure. Earlier it used to be only one figure, right? So far in the earlier programs, there was only one figure. So here you have plotted that this one, right? Alpha, omega, theta. So after that, you don't want this figure to be superimposed by other figure, or you don't want this figure to be closed. So that's why it gives you that hold on. So again, then next plot is created. All right. Okay, so now enough. I have given some you enough inputs. So that assignment problems now you should do, especially if you use the second program. That is which one is that? Underdamped system. Okay, I just open the program underdamped system. See, in the underdamped system, this is for zeta is equal to 0.1. So here you can manipulate the value for zeta is equal to 1 for critical damping, and then manipulate. You have to rewrite all the other equations also. Okay, you can keep some of the things as same, but the expression for x you have to change. For critically damped and for over damped, the equation is different. Okay, so accordingly you have to define some more parameters, and then you can write the same what you say, you can use this, modify this program itself, right? There was one question on plotting over damped, under damped, critically damped and undamped response, right, with respect to time. All right. I hope you are able to recollect this. You are able to correlate what I am asking you to do from your assignment work. Any questions? Because I wanted to show you one more thing. I will give you one
So,
more task to
hello,
do
sir.
before we. Yes, yes, go ahead.
Can you show the last part of this code? Yeah. Can you keep it here for like 2 minutes?
Yes, yes. Those who are done with the program can what do you say? Submit the final thing.
So,
So today's okay, yeah, yes.
sir, in which case we have to use that from and end, because in a second I think we didn't use that.
What? Which?
For and end, for and end syntax.
So this is for the loop, na? All these values are to be generated for the number of all these iterations, and I have defined the iterations earlier. So just click on iteration. Here, where do I define iterations? So I defined iterations over here. See, this way you can debug your program itself. See, if I click on iterations, it highlights all the variables. So iteration was defined in this step. So for all these iterations, I want to calculate omega, sorry, angular displacement, velocity, and acceleration. And also I want to calculate the tension. Is that what you are asking?
Yes, sir. So in second also we have got like a decrement wave. So in that we have got directly means in that why we have not used for and
Which one? I
so
didn't
the
actually get
previous one which we have solved, not this.
the earlier program.
Yes, earlier program.
There also we have done, na? So,
So what are we supposed to name
see,
this code?
see here, see x is equal to a raised to minus zeta omega and t dot. So here you don't need that, na? You are multiplying this entire matrix with this term. So you are getting a matrix of displacement for corresponding time, right? T here and x of t here, and you are going to plot. So you don't need that. Yes, what we are asking? Name of the program, uh, pendulum motion dot m. Okay, now before we end it, see, I want you to write a program that will create a graphical output of the motion of the pendulum. Okay, so I have already written that program. So that part of the exercise I leave it up to you. It is not an assignment. Okay, after the end of this two practical session, I will give the code for that. It is not an assignment. Your task for today's lab are only just these three programs and their output. All right, is that clear? Okay, so I will just so what I want to do using this program, create a like a graphical output of the vibration of the pendulum. So I will just run the program, because now we don't have time for doing this program, and I just run it. All right, so this is the So what it is done, the pendulum is brought to an extreme position, and then it is allowed to oscillate on its own. Alright, so as you can see, the amplitude goes on decreasing because it is a damped vibration. Alright, so I hope you got the idea. I'll just stop the video. Okay. So you can write this program. Now this is not the part of your what you say submission, but students can do this for extra credits. So there are 10 points for doing this if you can do this program. So the points for this are 25. Okay, but if you are able to solve this, there will be 10 extra points. So that is treated as extra credit. All right, so you can get 35 points out of 25. So 10 points will be extra credit. All right, as far as the submission for this, you have to do the first three programs, write the programs as I've described in the lecture and or in the practical, and then generate the output, attach the program and output, create a what you say a single PDF file. All right, for all the three programs. Any other questions before we end the session? Yes, anybody with any questions?
Sir, any other solution for those who don't have a laptop or PC like thing?
Means.
Sir, for those who don't have laptop or PC like thing where they can practice or can do anything.
See, now without computer, how can like you do this thing? You will need some basic. You don't need a very. I guess you will need some good basic PC. Where you can at least do computing. For Matlab, you don't need much. At least you should be able to install that program and run it. You don't need a very what you say. Even a Pentium will do an assemble PC. You can get it assembled for 15,000 rupees or something like that. You can get it assembled, and then if you have a television at your home, these days the television also has a VGA port, so you don't need to buy a monitor. You can just connect your desktop, assembled desktop, to your television, and you can run it as a computer. That is the cheapest possible solution for this. Do not. I cannot suggest. I don't know if there is any other possible way. You can easily assemble. You can even assemble it yourself. You don't have to go and buy it. Just buy the parts. Uh, it is very easy to assemble a PC. Just get the spare parts. Get the motherboard. All you need is a motherboard, processor, and a RAM. Right? And a cabinet. Just put it together. It's very easy actually. Hardly matter a few hours actually assembling a PC. You can buy it from Amazon or something like that. You can get it really cheap.
Hello, sir.
Yes,
Please check Shubh Shetty has uploaded that, sir, all the programs and that figure, sir. Shubh Shetty.
all the three programs. Just a minute.
Sir.
So even I have uploaded.
Shubh Shetty. Shubh Shetty. Yes, you have uploaded all the three. Uh, But also compile everything in a combined PDF and also do that also, right?
Okay, sir.
Yeah. So all the students are required to compile all these three programs and the outputs into a single PDF file, and then you can upload that also as the final response. Who else? Shubh Shetty and one more student was saying that uploaded all.
Sir, I have also done it.
Who is that?
Durvesh.
Sir,
Durvesh. Durvesh and
So I have also done.
Raj.
Raj Anatkar.
Vaishnavi also.
Okay. So Durvesh Devkar. Okay. Then Vaishnavi. Vaishnavi Nambiar. Okay. All right. Anybody else who has done all the three programs?
No, me, Raj.
Sir, yes, sir, Sanjeet.
Raj Anatkar.
Yes, sir.
Okay. Okay. Drop two. Okay. Drop four. All right.
Sir, Sanjeet.
The graph 3 and 4 is slightly blurry, yeah, Raj Anatkar. Sandeep.
Sir, I'll re-upload it again.
Haan. Sandeep. What is the last name?
Sir, Sanjeet Ramteke.
Sanjeet Ramtekar. Sanjeet. RS. Graph 2. All right. Okay, I have checked for some of the students. That's all right. Those who have finished can just turn it in. I will and also turn in the final PDF report. And if there are no other questions, so we can stop the practical for today. So this was using scripting. So today's session was Matlab programming using scripting, and so next we will be on based on Simulink. So in Matlab there is also one more package called as Simulink. So next practical session will be based on that. All right. Yes.
Hello, sir. Yeah, I just
Yes.
had a doubt. I downloaded the trial file. So
Uh-huh.
what exactly do we have to install? Like all the files or just
Just
some
do
of them?
just install everything.
All right.
That will be better because even I am not what you say quite sure what has to be excluded, or so I did a clean install of I installed everything, so that will include your Simulink
Yes, the
package also.
Simulink package. Yes. Okay.
So Simulink package should be there because next practical will be based on that. Okay, let me
Okay.
just
All right.
download the attendance.
Sir, for those who are using the online version,
Huh.
we can't save it in the desktop, right? It gets saved in the online drive.
Yeah, I think it will get saved in their drive, that online
Yeah,
drive.
sir. So
Yes.
how do we upload the PDF then?
You can just do a copy paste from there or take a
Okay,
screenshot.
So they
okay, we
can
can do
copy
that.
paste the notepad and then save it as .m file.
Yes, you can do a
Okay,
copy paste like just now what he has said.
all right, sir.
All right. Okay. Any other questions? Else we can close this session. So make sure that you have at least those who have not done it for today's session. Have the MATLAB ready in the next session. I will give the code after I complete the practical for B2 batch. All right. So if there are no more questions, we will end the session. All right. I will just stop the recording.